Hello and welcome. Have you ever wondered how two variables can be related in a mathematical equation? Well, that's what we are going to explore today, linear equations in two variables. It may sound complex, but trust me, it's not. Let's start simple. A linear equation in two variables is an equation where both variables appear only to the first power, no squares or cubes, just plain variables like x and y. The general form looks like this: a times x plus b times y equals c, where a, b, and c are constants, and x and y are the variables we are solving for. In the equation 2x plus 5 equals 0, you'll notice that x is the only variable and the equation is linear. The solution here is straightforward: x equals -5/2. This tells us that the value of x that makes the equation true is -5/2. Simple, right? Scene 2. Solving linear equations. Now, let's dive into solving these equations. To solve a linear equation like 2x plus 5 equals 0, the goal is to isolate x. Here's how you can do it. First, subtract 5 from both sides. 2x equals -5, then divide both sides by 2, x equals -5/2. That's it. You've solved for x. This solution represents the value of x that makes the equation true. You can visualize this solution on a number line where x equals -5/2 is the point on the line that satisfies the equation. Simple operations like addition, subtraction, multiplication, and division help us solve these equations step by step. Let's look at the general form of linear equations in two variables again. The standard equation looks like this: ax plus by equals c. This form can represent many relationships. For instance, in business, you might have pi plus 4y equals 9, where p is the price of an item and y is the quantity sold. Or in a simple scenario, consider the equation 1.2x plus 3y equals 5, where x and y represent two unknown quantities. These types of equations appear everywhere, whether in economics, physics, or daily life. Now let's make it visual. What happens when we graph a linear equation? Well, a linear equation always forms a straight line when plotted on a graph. Take the equation x plus y equals 3. If we plot points like 1, 2, and 2, 1, we can draw a straight line through these points, which represents all the possible solutions to this equation. So, every point on that line is a valid solution for x and y. This visual representation helps us understand how the solution works geometrically. The intersection of these lines is where the values of x and y satisfy the equation. Next, we have systems of linear equations. This is where two or more equations come into play. Let's say we have two equations: x plus y equals 5x minus y equals 1. These two equations together represent two straight lines. Where these lines intersect, we'll find the solution to the system. In this case, the point of intersection is 3, 2, which means that x equals 3 and y equals 2. There are different methods to solve such systems, like substitution or elimination, but the basic idea remains the same. We find the point where the lines intersect. You might be wondering, why do we need to know this in real life? Well, linear equations are incredibly useful. For example, in sports, imagine two batsmen together score 176 runs. The number of runs scored by each batsman can be represented by the equation x plus y equals 176, where x is the number of runs scored by the first batsman and y is the number scored by the second. Linear equations can also model situations in business, finance, and science. Whether you're calculating profit, distance, or time, you'll find linear equations everywhere. I hope you found this helpful, and that's how we deal with linear equations. See you in the next topic.